Hi, this is Elizabeth Stockdale. While I've been working from home, I've been taking the opportunity to catch up with farmers working as part of the AHDB BBRO Soil Biology and Soil Health Partnership. Here, I'm talking to Tony Bell from Thirsk about the soil biological indicators he'd measured.
Majority of the land is very light sand, blow-away sand, which means it's good for sort of carrots and potatoes, but not very good in terms of soil structure with organic matter. Sort of seeing the effect of over cultivation, and then we would see literally the land blowing away, and in the hedge back we'd have 18 inches, 2 foot of sand which had blown off the fields. And that was because we were ploughing it and then cultivating it. And it then led to more damage. And obviously then the crops that you were then sowing would then need resowing because they'd been sort of blown away. So we sort of said, we'll have to do it differently. And I started really running the farm 7-8 years ago. So then moved towards minimum cultivation with the objective, which we still haven't got there, of moving to direct drilling.
One thing you asked me to have a look at for you was this issue of, hang on, I'm putting on quite a lot of organic matter and why am I not seeing a response? What's going on in my soil? So the organic materials are straw going in. Is if it just sits on the surface of the soil, doesn't do anything very much. So it needs to be incorporated into the soil, whether by biological activity, but it's then either decomposed, so it turns into carbon dioxide, or it's stabilized and becomes soil organic matter. And it's a very simple balancing act. So it's a bit like my bank balance. If I pay more in, I tend to have more in the bank, unless I've happened to have said, oh, I'd like one of those, and I've spent the money. So the organic material coming in is either stabilized or spent. More of it that's going through that stabilization route, the more organic matter we'll get from the organic matter we're putting in. And that's where texture is really important. A very sandy soil has much less capability to stabilize that organic matter. The little rocks that are the sand grains don't have much chemistry going on their surfaces. They're fairly inert, so they tend not to make those interlocking relationships with the organic matter. So organic matter is just not stabilized as well. The kinds of things you were already doing, crop residue returns, your straw, actually good use of fertilizer to grow good crops. We talked about that, applying composts and manures and biosolids.
So having thought about the practices that Tony had in place, we had a look also at the soil health data that Tony had collected in the late autumn as part of the Soil Biology and Soil Health Partnership. And particularly we were looking at the organic matter first, measured by loss on ignition.
For a very light soil, 3.1 is a good number, Tony. So you shouldn't be beating yourself up about it.
All right. Okay.
I think an amber score there is going to be down in the 2s, certainly into the mid 2s. I think the boundary for this soil type between green and amber is 2.7. And the lighter the soil is in that sandy end, so towards loamy sand rather than sandy loam, actually the lower that boundary will be. The sand grains just don't have any ability to hold on to the organic matter and stabilize it. And so I think the worm numbers are also low, but again, just to note for you, that's probably our colouring in. I know your worm numbers are low, but actually no sandy soil that we've done any work on has shown high worm numbers.
No, I think there's only sort of one worm in each when it was after the wheat straw, and then in the rape straw, no worms, but you could see the holes, and then where there was no straw, no holes and no worms, so.
To give a deeper understanding of the potential of Tony's cropping system to accumulate organic matter, I'd reviewed his field data in the light of some published experiments.
So this is where I started to look at your data alongside some long data runs. So this is the Woburn Market Garden experiment, 18 years on a sandy loam, different kinds of additions from low rates to high rates. That's the difference in the colour of the symbol, and different types of material. So farmyard manure, composted farmyard manure, biosolids, and so on. And actually what they found was that it didn't really matter what material we were talking about. We got a fairly simple relationship simply between the amount of organic matter we added and how much carbon we ended up within the soil. That's just that bank balance thing. So we're putting more carbon in, we get more carbon in the soil. So I did the sums, roughly speaking, based on your straw, slurries, digestates and things. And I reckon you're around 190 tonnes of organic matter across, if we were doing it for an 18-year, so I could put it on here. And so you'd come in about there, which, you know what, is not far off where you're sitting in terms of your organic matter in soil. That's organic carbon. It's certainly not, it's not hugely different. What that told me, and should reassure you, is that, you know, it is possible to be an awful lot lower, and you're actually sitting on that higher slope of the curve for your soils. And another experiment, so this is total UK data, looking at the tonnes per hectare over whatever time period you like, against a percentage change in the organic matter in your soil. And that's now over one rotation. So that's me looking at that 6 years that you gave me. And I think that's a 34% increase in one rotational cycle compared with no input. So what that suggests is if you weren't doing that, so you weren't using the straw in the way you are, you still had all your tillage the same, you weren't putting on manures, your organic matter level would be back down to around 2.5s rather than the 3.1s and so on that you do have.
All right, that's reassuring.
Yes. I guess this is the most important thing, though, is that we get a bit hung up on what's the right level of organic matter. And actually the thing that matters is that the soil organisms are being regularly fed so that they can do your structure building and changing things. And I guess if I had a worry about your rotation, it's not that you use a lot of straw, it's that what are those organisms being fed in those crops in the middle?
Yes. Yeah.
And that, you know, I think what you do is clearly doing a really good job. You've got really good yields. There is nothing wrong, given the constraints your loamy sand gives you with your overall soil measurements. None of them make me scared or worried. They're about where I would expect them to be. But in terms of if you wanted to move them forward further, it's that question of, is there anything you can do rather than just put the straw on once to find something to feed the organisms in those winter crops in the middle? If you actually have compost around you that you're happy to take, and that's a key issue, and where the haulage cost isn't too silly. Because, you know, on those very sandy soils, those green waste composts will do a job for you in terms of helping that stabilised organic matter increase.
I think I will try and look at that.
And what about that soil assessment methodology, Tony? How was that for you?
No great hassle, and probably good to go out with a spade, because we always say we should go out with a spade more often. I must admit, I do keep a spade in the back of the car more now, because then you start it off and it then says, yeah, well, I should really sort of dig a hole more frequently and, try and assess the soils. We tend to, I think, too much of jumping off the tractor and walking over the fields as assessment, and I think we should be more continuous and digging holes.
Thanks to Tony for letting us share this chat. Hopefully it was useful, especially if you've got very sandy soils too.